Hey everyone, welcome back to another math moment. Today we're going to be going over logarithms and exponentials, which actually show up quite frequently in chemistry, so it's an important fundamental math concept to know. First of all, let's go over a little bit of definition. So I'm sure many of you guys have already seen this sort of expression before, where you have a number raised to a power. So in this case, I have y equals b to the x. So that's b raised to the x power. And when you do that, that gives you the value y. If you've never seen a logarithm before, it's basically just the inverse function of exponentiation. In other words, you're going to take the same equation, y equals b to the x, and rewrite it to where you have x equals something in terms of y. So you're basically switching x and y. And the way we do that is we define the logarithm function. So if we have y equals b to the x for some positive b, so there are some constraints on b. The constraints are b has to be positive and b cannot be 1. So if b satisfies these constraints and y is equal to b to the x, then the definition of logarithm tells us that if you take the logarithm of y base b, you will get x. In other words, the logarithm function answers the question, to what power do I need to raise b to get y? And the answer to that question is x. You need to raise b to the x power to get y. And that's all this logarithm function is telling us. And here I have a recap, y equals b to the x. That implies log base b of y is equal to x. Let's take a look at an example. Let's say y is 64, b is 4, and x is 3. So that means 64 is equal to 4 to the third. Alright, so 4 raised to the third power is equal to 64. So if I say log base 4 of 64, that's just asking, to what power do I have to raise 4 to get a final result of 64? The answer to that question is 3, because you need to raise 4 to the third power in order to get 64.